This is lesson 5.2, graphing square root functions. So the parent of a square root function is f of x is equal to the square root of x. So we'll plot these points and confirm that the graph pictured is this same graph. So when x is equal to 0, get the square root of 0. And the square root of 0 is 0. So we'll start here at 0, 0. When x equals 1, f of x is equal to the square root of 1, which equals 1. Now when x equals 4, take the square root of 4, which equals 2. So at 4, y equals 2. So that confirms that the graph pictured follows the parent function of f of x is equal to the square root of x. Now for transformations, this is the general form of the square root function. F of x is equal to positive or negative a times the square root of positive or negative x minus h plus k. So the a value will indicate a stretch or compression. If a is greater than 1, it's a stretch. If it's greater than 0 but less than 1, it's a compression. And these are the absolute values of a. And if a is negative, if there's a negative sign here, then there's a vertical reflection, which can be written as about a reflection about the x-axis. The value of h indicates a horizontal translation. It'll shift left if h is positive, or right if h is negative. K is the vertical translation. It'll shift up if k is positive, or down if k is negative. Now, if x minus h is negative, there's a horizontal reflection, which can also be written as about the y-axis. While the regular transformations are all the same as what we're used to, we do have a new sign change on x that we haven't seen in the previous graphs. So we'll go through some examples to see how it works. So the first example is what we're used to when we have negatives and reflections. This is when there's a negative a that comes before the square root of x. So first we take the square root of a number, and then we'll take the opposite of that answer. Enter is at 0, 0, and when we want to find the value when x is equals 0, we'll take g of 1 is equal to the negative square root of 1. The square root of 1 is 1, and we'll move the negative down. So when x equals 1, g of x equals negative 1. Now when x equals 4, g of x is equal to the negative square root of 4. The square root of 4 is 2, and its negative value is here at negative 2. So the red line is the original function, and the new black line that we plotted is the reflected transformation. So this is what it means when it says about the x-axis. See it flipped over the x-axis here. Now the other type of reflection is the horizontal reflection, which is about the y-axis. So we're assuming that it's going to flip over this line. So when x is negative, what kind of numbers can we use for x? We can only use negative numbers, because a positive number will give us a negative x, and we can't take the square root of a negative without incorporating imaginary numbers. So as an example, we'll take when x equals negative 1, negative 1 times negative is just positive 1, which equals 1. So when x equals negative 1, the answer is positive. How about negative 4? When x equals negative 4, get the square root of negative 4, which is the square root of 4, which equals 2. So negative 4, we plot it at 2. So here we see that the graph reflected amongst this y-axis here. So those are the two types of reflections, the vertical and the horizontal. We'll go through some examples and graph the following. So the starting point is -4, 0. There's no shift here, so we know that this value is 0, and the shift here will be the value of x, and x is equal to -4. So we're starting at -4, 0, which is here. And graph. So when x equals 0, we have the square root of 0 plus 4, which is the square root of 4, which is 2. So at 0, the value is 2. So we have this type of shape here. The starting point here is +3, x equals 3, and 0. There's no k value here, so we'll start at 3, 0. We can graph numerically. Go to x equals 4. When x equals 4, g of x equals 2 times 4 minus 3. The square root of 1, 2 times 1, which equals 2. We'll go through 2 more examples, and this time we'll list the domain and the range and all the transformations. So here there's no value of a, so there's no reflection or compression. There's no value of a here, so there's no reflection, compression, or stretch. There's a value of h here, though, that indicates that we'll move left by 3 units, and this value of k here that will move down by 2. This also means that our center, or our starting point, is going to be at -3, -2. So we can mark that, -3, -2. We'll graph a reference point where x equals -2. So when x equals -2, k of -2 is equal to the square root of -2 plus 3 minus 2. -2 plus 3 equals 1 minus 2 is 1. 1 minus 2 equals -1. So when x equals -2, y equals -1. And I'll sketch the general shape of the graph here. So for the domain and ranges of this graph, the domain is when x is greater than or equal to -3, because we see here that this part of the graph, there's no points there. So x has to be greater than or equal to -3. So that's everything on this side of the graph. And so the range is y is greater than or equal to -2. Because we see here, there's nothing down here, and the graph only moves above -2. So the transformations for the second example, we see that there's a value of a here with no negative sign, and it's a value greater than 0, so there's a stretch by 2. It'll shift right by 2. It'll shift up by 1. And there's going to be a horizontal reflection. So our starting point is at 2, 1. We see here 2 and 1. So we'll plot the point n of 1. So when x equals 1 is equal to 2 times the square root of negative 1 minus 2 plus 1. Negative 1 negative 1, which is just 1. So 2 times the square root of 1 plus 1. Y equals 3. So at x value of 1, y is 3. So the graph is going this way. So we know that the domain is the values of x less than or equal to 2. And the range is the values of y greater than or equal to 1. You see here that when y equals 1, that's the minimum value of the graph, so everything has to be above that. And here, x equals 2, and it's moving in this direction. So everything has to be greater than or less than negative 2. Finally, we'll write an equation for each graph function based off of the parent function. So we'll write our reference points. If this is 0, 0, this point here is 2, 0, and there's another point here. At 3, negative 1. So with these values, we know that our starting point is at 2, 0, and we know that there's a vertical reflection so we know that the value of a will be negative. If we start with the y-coordinate equal to 0, we know that there's no value of k, so we can write the function as f of x is equal to negative, here for our vertical reflection, square root of x minus 2.